Okay, so you should be looking at 13.2, independent events. So what we're going to do now is we're going to talk about how you can determine whether two events are independent or dependent. So here we go. Independent events. So when the occurrence of one event does not affect the occurrence of the other, they are said to be independent. So two events A and B are independent if and only if the probability that both events occur is the product of the probabilities of the events. In other words, the probability of A and B happening is equal to the probability of A times the probability of B. So let's take a look at that kiddo that took that quiz a while ago. Remember, there are 16 possible outcomes. What I want to know is I want to use my sample space down here to determine whether guessing question 1 correctly and guessing question 2 correctly are independent. So the probability of question 1 correct. So go through and look at all the possibilities. Question 1 is correct there. Question 1 is correct, correct, correct. 1, 2, 2, 2. And we get that there are 8 out of 16 times where question 1 was answered correctly. So that would be 1/2. Okay, so now what is the probability of question 2 being correct? So now look at question 2, so the second slot. So there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 out of 16 times that question 2 was also correct, which is also 1/2. Now I want to know what is the probability of question 1 and question 2 being correct. So now I want to look at 1 and 2 being correct. So now look in your spaces here for 1 and 2 being correct. There's 1 right there, 2, 3, and 4. So that's 4 out of 16, which reduces to 1/4. So now I want to check this scenario up here where they said the probability of both has to equal the product of the two together. So is 1/4 equal to 1/2 times 1/2? Yes. So therefore these are independent. So these are independent events. Easy enough. All right, so now as part of the board game, we have 8 sections. And we want to find the probability that we get a 5 on our first spin, so the probability of a 5. And then I want the probability of a number greater than 3. So what's the probability of a 5? Well, there's 1 5 out of 8 times. And how many numbers are greater than 3? 1, 2, 3, 4, 5. 5 out of 8. So that becomes 5/64. So 5/64 is approximately 0.078 or 7.8%. So the probability of you spinning and getting a 5 on your first spin and your second spin being any number greater than 3 is about 7.8%. Okay, now let's talk about dependent. Dependent is when something does affect the occurrence of the other event. So let's say that we've got event A. So our first bill is 100 and the second bill is 100. So think about it like this. You have a bag. Your bag contains 20 $1 bills and 5 $100 bills. You randomly draw a bill from the bag and you put it to the side. Then you randomly draw another bill. So this is without replacement. So without replacement. So explain why this situation is an example of dependent events. So the number of outcomes for the second event decreases because you did not replace. So the number of outcomes decreases because you did not replace the bill after the first drawing. All right, so find the probability that both events will occur. So I want to know the probability of A and, oops, times the probability of B. Well, the probability of A. What is the probability that my first bill is 100? Well, there's 5 $100 bills in there, and there are 25 outcomes because there's 25 bills. So 5 out of 25. So I reach in the bag, I draw a bill, it's a $100 bill. I have a 5 in 25 chance of that happening. Times, I set it to the side. Well, since I drew a $100 bill, the second time I want to draw a 100, there should only be 4 of them, and there should be 24 bills in the bag now because you took one out and set it to the side. So when you go through and multiply this, you're going to get 20 out of 600, which is about 0.033, or better yet, 3.3%. So you've got about a 3% chance of drawing 2 $100 bills in your first 2 drawings. So not very good odds. Possible, but not likely. All right, now you're trying to guess a 3-letter password. So you're trying to guess a 3-letter password. You only get 6 letters to choose from. And they can be used more than once. So basically that's like saying replacements. Find the probability that you pick the correct password of U. So I need the probability of Y, O, and U. So there is 1 Y out of 6 letters. There is 1 O, and there is 1 U. So you got about a 1 in 216 chance of guessing the right password, which is about 0.0046. Better yet, 0.46%. It's not even 0.5% likely of guessing a 3-letter password from 6 letters. Think how low it would be if you had to choose from 26. So now you're trying to guess another 3-letter password. You're still using the same 6 letters. This time you cannot replace them. So now the probability of A, I, and E. So the probability of A is 1 out of 6 because there's 1 A out of 6 letters. But now you set it to the side because you cannot use it again. So now the probability of an I is 1 out of 5, and the probability of E is 1 out of 4. Well, your chances are a little better because now it's 120, which is about 0.0083, or almost a 1% chance of guessing the right letter if you can't replace it. All right, and our last part is using a table. So what we're going to do, this is kind of like the pizza thing. You're going to go through and add up all your numbers. So you add up your soccer players. So there are 73,763 soccer players. There are 59,865 basketball players. There are 69,103 male players. And let's see, 36,523 plus 28,002. And then there are 64,525 female players. So all together, there are 133,628 players altogether. So the first thing we want to do is we want to find the probability that a randomly selected collegiate soccer player is female. So first of all, I want to find a female collegiate soccer player out of all of these soccer players. So there are 36,523 female soccer players, but there are 73,763 soccer players altogether. So if all the soccer players are standing in a room and I randomly draw someone's name, what is the probability that it's a female soccer player? So that is about 0.495%, oops, 0.495, which is about 49.5%. Sorry, I put the percent almost too soon. So we want collegiate soccer female. So our next one, find the probability that I randomly selected male. So now we want to choose from the male. So now we want to choose from the male players, but we want him to be a collegiate basketball player. So now I want a basketball player. So collegiate basketball player. So we're choosing from the males. So our male players are 69,103. Out of the 69,103, there are 31,863 that are basketball. So what is that? It comes to 0.461 or 46.1%. So here it says to randomly select a male. So you want to only look at your male students. So that would be all of these. But we want him to play basketball, so you have to choose from the males. So 31,000 out of 69 is about 46%. So you have a 46% chance. Okay, so you should have picked up your homework as well, and I will see you guys next time.